So this is question number 6 on the graph theory homework. It says to apply the repeated nearest neighbor algorithm to the graph above, and starting at which vertex or vertices produces the circuit of lowest cost. So you're going to have to find the cost of the circuit from each of the 6 vertices, and then figure out which ones are cheapest. So let's just go through a couple of them to see how you would do that. From A, if you start there, the cheapest place to go is D. That costs 1. There from D, the cheapest place to go that's not going back to A is up to C, and that's going to cost you 7. From C, the cheapest place to go, you have a choice between F and E. F is cheaper, that's going to cost 4, so you're going to go to F. From F, you don't have a lot of choice. You can't go all the way back to A yet because you haven't done the whole thing. You can't go back to C, so you have to go to B for that 15. And from B, your only choice is E, because that's the only one that doesn't take you backwards to something you've already visited, and that's 3. And then E to A will close the circuit, and that costs 5. So when you add that all up, you get 35 for the cost of that circuit, starting from A and using the repeated nearest neighbor algorithm. And you will go through and do those for each one of the vertices. So let me just tell you what those are. You go through and do it and see if you can replicate this. From B, it's going to be B, E, A, D, C, F, B for a cost of 35. From C, it will be C, F, A, D, B, E, C for a cost of 36. From D, it will be D, A, E, B, F, C, D for a cost of 35. From E, this is going to be your most expensive one. It's E, B, D, A, F, C, E for a cost of 46. And the last one from F will give you F, C, D, A, E, B, F for a cost of 35 total. So you'll find that you have 4 circuits that cost 35, and that's the lowest cost. And they start at A, B, D, and F. So that would be the correct answer to this question. This is question number 9. And you're asked to find the minimum cost spanning tree on the graph above using Kruskal's algorithm, and which of the edges are included in that minimum cost tree. So you always start with the cheapest. What's the cheapest edge here? Well, the cheapest edge is BD, costs 4. What's the next cheapest edge? That's AD. That does not close the circuit, so it's okay to choose that. So AD would also be included in it. The next cheapest edge is BC, which is 6. And we can choose that because it doesn't close the circuit. But at that point, we have spanned it. Okay, we have made a tree. Every place is connected somehow in there. So it's those 3 edges, BD, AD, and BC, that will be included in that minimum cost spanning tree.